Hello and welcome to TM Atlantic channel. Today is a tutorial on how to repair a modern LED light fixture and how to redesign LED driver to reduce current need for repairs. Also, if you want to get our new videos, don't forget to subscribe to our YouTube channel and turn on the bell.
Today we're repairing a light fixture that is composed of 3 sections and all of them do not light up. We can see that there is one driver installed for all 3 sections. Obviously, the driver is faulty. If the driver was working properly, then at least one section would light up, therefore we disable the driver. The repair seems simple, repairing the driver itself. Remove the driver. As soon as we remove the cover, oops! The driver is filled with compound and repair is difficult and not worthwhile. We need to find another inexpensive driver that matches these parameters 27 to 42 volts and a current of 600 mA. The search for a completely identical driver is unsuccessful, but there is an option of 3 drivers that are not very expensive, however they all have a higher current. This will work for us, but we will need to redesign the light fixture. It was designed and laid out with 1 driver, now let's change it to 3. It even will be more reliable. If one driver breaks, the rest will work. However, we need to change the current of the new driver. Calculating the required current is simple. Divide 600 mA from the old driver into 3 lamps. We get 200 mA. Looking at the new drivers, they have 300 mA. It's a lot. We need to reduce it and we'll have to do the calculation and verify it. First, let's check that the new driver is working and all sections are in good condition. To do this, we'll connect 2 sections to the new driver so as not to exceed the current of 200 mA per section and measure the brightness. We turn on multimeters and external voltage. Obviously, the brightness of each section is less than nominal. We connect all 3 sections and see that all sections are working properly. And our assumption at the beginning about the driver malfunction is correct. Here we see that the driver current for LED is 257 mA. Let's look at the new driver without the housing. It uses a 6613S type chip. The driver diagram for this chip is on the website. The link will be in the description under the video. In this circuit there is a resistor R3. This is a current regulator through the LED. In the driver itself, resistor R3 is made in parallel with the resistor RS, marked 2R0 and color code resistor. We go to our website and determine the values of both resistors and the total resistance. First, enter the SMD resistor code 2R0, it is exactly 2 ohms, and then the color code with 5 stripes. We get 2.4 ohms. We know that these resistors are installed in parallel. Let's go to the calculation and add these values and get the total resistance. According to the calculation is 1.091 ohm. To check the accuracy of our calculation, let's measure its resistance. We use our advanced digital multimeter Octacom AM1060. We talked about its functionality in the earlier video. The link will be at the top of the screen and in the description under the video. We set the resistance measurement mode. We get 1.2 ohms and check the resistance of the wires. It's equal to 0.1 ohm. The resistance of the wires must be subtracted from the measured value of 1.2 ohms. Thus, our calculation and measurements coincide, and according to the diagram we have resistor R3 equal to 1.1 ohms. Next, we need to change this resistance to reduce the current in the LED. We know that with the value of resistor R3 1.1 ohm, we have LED current of 257 mA and we need 200 mA. We take the datasheet and see that it is in Chinese. Learning the Chinese is not part of our repair project, so we need to experiment. A simple question: by what percentage do we need to change the driver current to get a current of 200 mA? It is simple. 257 minus 200, we get 57 milliamps, which is approximately equal to 22% of 257 milliamps. Let's assume that we also need to change resistor R3 to 22%. Moreover, we need to increase the resistor. Why? Again, the answer is simple. Larger resistance will give a greater voltage drop in the control circuit, and this will lead to a drop in current in the LED. This is exactly what the LED driver is used for. 22% increase in resistor means 1.1 ohm multiplied by 22% equals 1.33 ohms. To do that, we need to select a pair of resistors with a total resistance of 1.33 ohm. At the same time, there is a 2 ohm SMD resistor on the board. We won't touch it. We use the calculation on our website for a parallel connection and get a missing resistor of 3.97 ohms. To verify our calculation, we solder one terminal of the resistor with a color code. Dismantling can be conveniently done with a special desoldering iron and station Octacom SE2101. The link to the desoldering station will be in the description under the video. Next, add 1.5 ohm resistor in series. Thus, the total value is 2.4 plus 1.5, which equals 3.9 ohms that is required by calculation. We connect the driver with the new value of resistor R3, current regulator. This value is 22% higher. Let's turn it on and get a current in the light fixture 206 milliamps. Great, we are on the right track. We installed a new resistor R3 equal to 4.3 ohm instead of the old 2.4 ohm. We connect it and turn on the voltage. As you can see, we received a current of 196 milliamps, so we did everything right. Next, you need to assemble all the drivers in the same way. As a result of this redesign, we get a new and more reliable LED light fixture. It has 3 sections, each with its own driver. This is how we repaired the light, changed its design and increased its reliability. And why are we so confident that the LED light is now more reliable? It is simple. The temperature of the LED driver's transformer became lower after our modifications. In the infrared photo, the temperature was 59 degrees and became 37 degrees Celsius. Great! Lower device temperature is the key to long operation.
Thank you for watching the video. Please don't forget to like it. We hope it was useful for you. Also, if you need to repair your favorite LED light fixture, contact us. The link will be in the description or visit our website. Bye bye and see you later.